Hello everyone, welcome to today's session. My name is Alex Ruheni, a student partner from Kenya. A little bit about me, I am a beta student partner as well as a front-end engineering intern at a company called Turnkey Africa. The MSP Kenya Community is brief about that. The MSP Kenya Community is a community where our main aim is to bring together students from all universities in Kenya and to empower them and learn technologies that can help them out there in the workspace, in the work environment after campus. If you have any questions during this session, feel free to post them in the chat. And I would like to welcome our guest today. His name is Burk Holland. He is a developer advocate at Microsoft, and I will let him take it away from here.
All right, thanks for having me. I'm going to turn my camera on. Is it working?
Yes, it is. We can hear you and see you as well.
Okay, can you see all of me or just the top of my head?
All of you.
Okay, good. I've got this new camera set up and it's been breaking all week, so I appreciate the patience. So hello, Kenya. Thank you for having me. What time is it where you are?
It's currently 8:06 p.m.
Oh, wow. It's 8 o'clock at night on a Friday, nonetheless. You should be, I was going to say you should be out doing something, but I don't know. Are y'all allowed to be out? We're not supposed to be out here.
We currently have a curfew from 7 p.m. till 5 a.m.
Ah, gotcha. So it's the same here. We don't go out much. We stayed home. We're playing a lot of video games.
Oh, okay. We are trying to make use of our time as well.
Yes, some sort of a quarantine project.
Yes.
Well, thank you for having me. This session is going to be called The Good, the Bad, and the Ugly. And we went back and forth about JAMstack and serverless. And we're going to talk about JAMstack and we're going to talk about serverless. And those two things are more closely related than you might think. So let's get right into it. I assume everybody can see my PowerPoint?
Yes, we can.
Okay, great. So let me get back over there. There we go. So my name is Burke, and I work as a developer advocate on the Azure team at Microsoft. And this presentation actually was done, we did this at Build last year, and it's a project between myself and my colleague, Cecil Phillip here. And we travel around a lot, and we tell people about Azure and about serverless. And in order to tell people interesting things about Azure or serverless, we have to know these things ourselves. And that means that we have to build things. We're not just magically endowed with knowledge. We also have to build things in order to figure out and have interesting things to tell you. And so we're always looking for what we can do, what we can build to tell you something interesting. And we wanted to build an application that was a JAMstack or a serverless application, and we'll talk about what that means here in a second. But first, I want to talk about what we built, and then we'll talk about how it's built. We weren't really sure what demo to build, though. People build a lot of demos. There's Hello World demos, there's to-do lists, there's lots of demos. We wanted to build an application that would allow us to build this sort of serverless JAMstack type application on Azure, but we wanted it to be useful. Not just a demo, but something that maybe people would actually want to use that solved an actual problem. We needed it to use Azure, and we needed it to provide real value to developers in terms of building things with serverless technologies. So what to build? That was the question. Well, we were doing a conference together in Las Vegas, and we noticed this sort of strange pattern while we were in Las Vegas with the different sessions that we were at. And the pattern that we noticed was in every presentation that either we gave or other people were giving, they would go through their presentation, they would convey some idea or some new feature or some cool technology that made you want to go home and work with that thing or build something with that thing. And then at the very end of the presentation, they would put a list of links on a slide. Like, here's all the different things you can go do. Here's some tutorials. Here are some articles. Here's some icons, what have you. And then everybody would take their phone out of their pocket and take a picture of the slide and then go home, I assume, and do nothing, because you're just not going to type in links off of a tiny photo on your phone. And so we thought that that was kind of crazy that people were doing that, and that wouldn't it be easier to have one link that pointed to all of the other stuff that you wanted people to have. So instead of having to remember or take a photo of a bunch of links and then type them in, they just had to remember one easy to remember URL. So we decided to think of this as a way to distribute to people lists of URLs, or a URL list, if you would. So we built an application, and it's called the URL list. And I'd like to show it to you real quick. So I'm going to change my sharing real quick here in Team. And let's take a look at what the application looks like. So let's come over here where I was trying to figure out how to share content in a Teams meeting. And let's take a look at this application. So I'm going to go to the URL list. So this is the application that we built. It's running live. You can go to it right now. And let's say we wanted to create a list of links. So let's say one of the links that we wanted to give to people was, actually, we have a good article here all about the application built. So we want to give them this right here. Let's say we also want to give them get started with Azure Functions, a little bit of serverless tutorial. So let's go ahead and add in a link for that as well. And then let's do one more. Let's say we wanted to give them an article on get started with Cosmos DB. So let's find one of those links. Here's a good one. And then we'll pull this one in and paste this one in as well. And so we've got now this sort of list of links. And as you can see, we can actually drag these things around and reorder them. And then what we can do here is we can give this thing a description. So a list of links that might be helpful for people building apps. Okay. And then we could go ahead and publish this, and it would give us a URL that lands on these three links. Or we could give it a vanity right here, a vanity URL. So let's say this is just my custom URL, or let's, you know what, let's call it MSP Kenya. There we go. So we'll click publish. And then I don't know if the zoom is going to work for everybody, but you can see up here at the top that the URL here, so you can actually go to this right now. This is live, and then you actually get to these links here. And then we added in a authentication mechanism, so we'll authenticate here. And once you do that, then you can actually create lists and manage them. So here's a good one right here. So this one was from build. So here's all the resources we wanted to give people. Let's say I decided I wanted to add in this introduction to Cosmos DB. I can come and do that. It'll go down to the bottom here. Let's say I want that to be super important. So let's put that at the top. And it will just go publish. And now this list is updated. And if we scroll down, you'll see the introduction to Cosmos DB. So we can actually change lists on the fly as well. And then, y'all, check it out. We just put this in QR code. So you can still take your phone out and scan the screen, right? Because that's what everybody wants to do. So that's the application that we built. I just wanted to show that to you because it is a non-trivial application. It's of some size, and all of that application, every bit of what you just saw, is running on Azure, and it's got a lot of pieces. And in fact, this application is what we would call a JAMstack application. What does that even mean? Sounds cool. What does it mean? Well, JAMstack is an acronym, and it stands for JavaScript, APIs, and Markup. And the stack is on there just to make it sound awesome. JAMstack is not a technology. It is an architectural pattern. The most important thing that you need to know about JAMstack is that it does not require anywhere in the architecture a traditional application server. So you can think of JAMstack applications as serverless applications. It's an interesting connection. Now, to make the parts of this more clear, JavaScript, APIs, and Markup, I want to show you the parts of the URL list, excuse me, and how the JAMstack fits in here. So the URL list is composed of 3 different tiers, right? So it's traditional application architecture in that fashion. So the first tier is the front end, which is composed of Vue and TypeScript. So that is the JavaScript and the markup portion of the application. The middle tier is composed of C# running on Azure Functions, which is serverless. That is the API portion of the JAMstack. And then the back end is running on Cosmos DB, which is the database. So this seems like just another web app. What is it about it that makes it a JAMstack app? If I say JavaScript, Markup, and APIs, isn't that just every single web app that's ever been made? It's confusing. The answer is it is, except for the serverless portion is what makes this different. And so the way that we're going to architect and deploy this app is going to be familiar, but at the same time, we're going to use some different solutions to do it. And that's what makes it a JAMstack application. So we're going to look a lot at Azure today. This is not an Azure sales pitch. If it is an Azure sales pitch, it's not a great one because there are some good parts of building apps this way. There are some bad ones, and there's downright ugly ones. But we do believe that developers are best served when they know how things do and don't work in Azure and how to make their applications work inside of that environment. And so that's what I hope to show you in this presentation. And this application is fundamentally different, as we talked about, because all the pieces are serverless. So let's talk about that difference for just a second here. Serverless is kind of a buzzword, isn't it? Like, what does it mean if I say that something is serverless? I throw that word around, but I haven't actually defined it. Now, I believe that serverless is not a technology or a product, but it actually has 3 distinct pieces. So there are 3 rules that we've come up here that makes a technology serverless. The first rule is that the technology that you use has to make it so that you have no knowledge of the underlying technology that's being run. The second thing is that you should only pay for what you use. If you're not using it, then you shouldn't have to pay for it. And the third one is that scaling should just work in the application. In other words, you don't have to add any servers. You don't have to add more CPUs or more memory. You don't have to know about any of that. It just scales automatically. And that's true, should be true for the front end, for the API, for the database, for all of it. So if we look at the URL list and we pull back the lid on the application and the architecture, there are really 2 core services that make this not a traditional application, but a serverless one and a JAMstack application at that. Did I go back? Have I shared my PowerPoint back here? I don't know that I did.
No, we are currently seeing your browser.
Sorry, let me share my PowerPoint. There we go, that's better. Apologize about that. So let's pull the lid back on this serverless app and take a look at it. Underneath it, there are 2 components inside of Azure that actually make this thing serverless. So one of them is something that you've probably heard of before, or you might have heard of before, and that's Azure Functions. And there's a second component here that actually makes this serverless, and that's Azure Storage, which is going to be a very interesting component in how this application is structured and really what makes it a JAMstack application. So let's talk about Azure Functions here. Functions is the product that you would probably typically think of as serverless inside of Azure. And this is because it's marketed that way. It's like Lambda in Amazon or Google Cloud Functions. We market it as a serverless solution, and so people tend to think serverless, oh, that's Azure Functions. Now, serverless platforms like Azure Functions are tremendously well suited for APIs. And this is specifically because when you're building an API, you don't really care about the web server, do you? You really don't. You don't want to have to write controller methods or routing and all of, you're only doing that because you have to. What you're really trying to do is usually get some data and display it or update some data in a database based on data that was passed in. 99% of APIs do just that. And so anything that doesn't deal with doing just that is actually something that you would rather not have to deal with. And so any of the web server logic in Azure Functions, such as starting the server, how the URLs are served, what libraries are used to process requests, things like that, you don't care about any of that. It's just that you have to know about it to build your APIs. And serverless abstracts all of that away so that all you have to do is write the code that you need to write, and everything else will just work inside of the Azure function in terms of handling the HTTP request. The other portion here is Azure Storage. Now, why in the world would we look at Azure Storage for a web application? That doesn't even make sense. Wouldn't we normally put files in Azure Storage? Isn't that what it's for? Big files? Well, the other part of our application is our front end. And front ends these days are increasingly static. Now, what I mean by static, when I say the word static, what I mean is that there is no server-side component to the application. In other words, there's no ASP, ASP.NET, JSP, or personal home pages. Has anybody heard of personal home pages? I bet you have. You just haven't heard it said like that. That's PHP. So those are server-side runtimes that are altering the page or the markup and then sending it down to whoever's consuming it. So all of these things that a server might normally do in a web app, so make a request for data, assemble templates, route requests to pages, all of this is now handled by JavaScript on the front end. The JavaScript is literally doing everything. It's just all happening in the browser and not on the server. And because it's not happening on the server anymore, this means that you don't actually need most of the web server. You don't need Express, you don't need ASP.NET, you don't need the PHP runtime. All you need is something that can serve up an index.html file as fast as is humanly possible or computer possible. And as it turns out, hosting providers like Azure and EC2 are really, really good at doing this. This is one thing that the cloud is fantastically good at, and that is serving files very, very fast and scaling like you would not believe. We've been storing and delivering files from the cloud for a very long time, and so we know how to do it really, really well. And since the site is just a folder of static files, that means the files don't change on the server. They're compiled in the development process, put on the server, the user pulls them down, the JavaScript runs in the browser and does all of the processing there. Because that's the case, we can actually use Azure Storage to serve up the front end. All right. So that is our intro to serverless web apps, or JAMstack. These things are the same. So you can think of JAMstack and serverless web apps as being the same. The important components are that the front end is static. And remember, that means it doesn't have any server component that's altering the page or building the site on the server. It's all done in the browser. So think React, Vue, or Angular. And that the middle tier, the API, is serverless. So it's running on Functions or Lambda or GCP, something like that. All right, so let's start with what's good, at least in Azure, about these types of applications, JAMstack applications. All right, so there's a couple of things that are quite good. We can't talk about all of them. We don't have enough time to do that. In fact, we're already almost halfway through here. But let's talk about some of the ones that we've got here. So these are some of my favorites here. The first one is going to be cost. Let's just talk about money because that's always the most important thing. Assuming that we don't have infinite resources, and we definitely do not. When Cecil and I built this app, we did it as if it's just us. We don't work at Microsoft. We don't have free Azure accounts. We actually have to pay for this. What's the cheapest possible way to do this? So serverless is an incredibly cheap way to build your applications because there's no server. And if there's no server, then there's nothing to pay for. So what do you pay for in Azure Functions? Well, in Azure Functions, you pay what we call per gigabit per second or compute time. And so, in other words, how long does it take your API to execute? As long as it's running, you get billed. And then the other thing is that you pay a flat 20 cents per million executions, but you get the first million free every month. And we'll look at how the cost actually breaks down for the URLs, and you'll see that we run at about 60,000 requests per month, which is not a lot, and we pay virtually nothing. Storage is the same way. So on storage, you pay per gigabyte that you use actual storage, and you pay 6 cents. So that, I mean, that's nothing, especially since the website, you know, a website is how big? All of your assets and everything, maybe a couple of megabytes at the most. And then the other thing is that you pay 0.087 cents per gigabyte coming out. It's actually not in and out, it's just out. So that's one of the things that we'll talk about later, because bandwidth is something that we need to discuss as one of the not great things when it comes to cost, but we'll talk about that. But storage in and of itself, not talking about how much data you're pulling out of Azure, the storage service itself is also extremely cheap, and you get the first gigabyte per month free on that as well, which you're not going to get anywhere close to with just a website. So that's cost, and obviously we want you to spend money on Azure, but we also want you to be successful, and we want your business to be successful, and we want to show you what we think is the fastest and cheapest way for you to do things, because as fellow developers, we would appreciate it if somebody showed us that, so we're showing it to you. All right, so the next thing that's really good about this JAMstack serverless web application architecture is speed. Now, the only way for me to show you this is to actually demo it for you. So I'm going to do that. So I'm going to come here to Teams and stop sharing this screen. And let's go back over to our other screen here. Let's go to, let me just share, I'll tell you what, let's just share screen 2, I think. All right, can everybody see VS Code?
Yes.
Not yet.
Can you see VS Code? Do you see it?
Yes.
Okay. All right, so this is the front end application. This is it. It's written in Vue and TypeScript. So all of these files over here, when we're coding, you can see there's a lot of them. But when this thing is built, let's do this. I'm going to do npm run, npm run build, and that's going to kick off a build. And so if you've not used one of these front end frameworks before, you build with the framework, and then when you're done and ready to deploy it, there's actually a build step where it takes all of these files and folders over here, and it minifies and concatenates everything down, and then what you get at the end is this dist folder here. And what's inside of this folder is an index file, right? And then some JavaScript and some CSS, and then your images. That's it. That's the whole application compiles down to just this. So really, all we need to do is serve up the contents of this folder. So before this session, I created this storage account here, and I'm just going to say browse static website to show you that there's nothing here. Okay, so we've not put any content up here. Now what I want to do is just show you the raw speed of this thing. So what I'm going to do is I'm going to come back here and I'm going to deploy this app to storage just while you're watching. So I'm going to say deploy to static website, and we'll find the account that I made. And what it's going to do now is it's going to deploy this dist folder from my machine up to Azure. So you can see that happening here. It's just uploading that folder as it is directly into Azure storage. And my internet's a little bit slower here now that everyone in the entire United States is at home. Now, I'm going to click Browse to Website, and I want you to watch how fast this site loads, okay? We've never been to it before. This is a fresh deploy. So I'm going to say Browse Website. It's going to open a browser. Boom. There it is. That's the whole app. That's it. There's no container to start up. There's no runtime to prime. There's just no comparison when it comes to the speed that you can get from a static web app, so a Vue, React, Angular app. The raw speed is incredible. And running on something like Azure Storage, you saw how fast my machine was able to pull that down. It really is an astounding technology. All right, so that was the speed. Let's look at some other things we really liked about this. Let's look at, what's another one here? Let's look at the scale. Scaling is an important thing, and often something that when people talk about serverless, they say that this is a very, very important thing, and it is a very important thing. It is something that we don't normally think about, but we kind of just expect that the cloud will do it. The cloud does scale, but it doesn't happen automatically. So for instance, in Azure, if you use a normal application server, what we call app services, you have to add in additional instances in order for it to scale out. Now it's just a slider, but you still have to do it. And every time you do it, you're adding in another instance, and those instances cost, you know, $32 a pop every time you add one in. So you're paying for all of that compute whether you use it or not. And what we wanted was a solution that would just scale automatically. And then the other one was, we'll look at these other good things, and then we'll look at some demos here. The local development experience. So development experience for functions and for the front end inside of VS Code is just really nice. So we were able to do all of our front end and debugging from VS Code, including the serverless API, and not have to rely on already deployed services or have it be, you know, completely obscured to where we couldn't see what we were doing. We could debug everything locally, which was really nice. And then the last thing was the CORS. So CORS is an acronym for cross-origin resource sharing. And what that means is that if you have a front-end application running in one spot on storage and you have an API that's running in Azure Functions, those are running on two different URLs, and they're not going to be allowed to talk to each other. And that's because of something called content security. And so basically your browser does not allow you to consume an API from another server that's not on the same domain that you are. And that's to protect you. And so to get around this, there's a feature called cross-origin resource sharing, where you basically tell the server, hey, it's okay for this particular URL to access your API. And with Azure Functions, that's a relatively easy thing to turn on or turn off. So let's go back and look at some of these things here. Let's take a look at, let's go back here. So I'm going to go to, let's go to screen 2. And let's take a look at, the scaling thing first. So when we don't have a server, it is, how do you monitor and figure out what the load on your server is or how your server is doing? Well, in Azure, there's something called Application Insights, which will do that. So the Application Insights is tied to our Azure Functions. It knows about it, and we can actually look at some of the live metrics that are coming in from our site. So Application Insights tracks our site across the front end, which is on storage, all the way through to the Functions API. Now, what I want to show you in this demo here is, let's scroll down a little bit. If you look down here, you'll see there's servers, okay? So what I'm going to do here is I'm going to go ahead and launch a bunch of requests against the service, all right? So I'm going to do something called, I'm going to use a little tool called Artillery, and that is going to start hammering this service with requests, and you'll watch them come in. Now you're going to see a bunch of them fail, and the reason for this is that we've got the database actually locked down, so the database will not respond to any more than 400 requests per second, and that's to save on cost. So we basically capped it and said, if we're getting more than 400 requests per second, which is a lot, that's too many. But what I want you to notice is, you see what's happening down here? It's going to start adding servers as these resources get consumed. So what's happening is Azure Functions is just adding in servers as we need them. And then when the load decreases, right, when this artillery, when I stop hammering my own site, then it's going to start removing servers and going back down to an acceptable number. And it'll actually go all the way back down to just one server if there's not much traffic at all. So that's scaling. It just works. You know, we didn't have to do anything to do that. It's all handled by Azure Functions, which is a core tenet of serverless, which is that it should just scale and you shouldn't have to worry about it. And so we can actually check back on this in a second and see if we've got more servers here. Yeah, you can see it already took away one. So it's scaling up and down, which is really nice. So let's take a look at the local debugging, which was great. And let me stop this artillery so my poor server can be okay. So over here on, this is the API for our project. And so, and actually let me open, I'm gonna open a different, so that's, let's see. I'm gonna open the, I'm going to go into the source folder, and I want to open, I just want to open just the functions project. That'll work. All right, so this is just the functions project, and this is a C# project running inside of VS Code. And we can actually run this project locally with the run and debug here. So as soon as this, I'm waiting for it to kind of load up here. I think it's about done. But what we can do is we can actually run and attach to these functions locally. So we can debug our Azure Functions locally inside of VS Code. Now what's interesting here is that Azure Functions gives you the entire runtime, the same runtime that it uses on the server, and it allows you to run that locally. And so you know that the functions, if you build them locally and they work, then they're also going to work when you deploy them to Azure, which is super nice. And Azure Functions configures all of this for you, so you don't have to figure out how to get the debug configurations just right. It puts it in there. Mine's running a little slow because I think it's probably doing a build here from OmniSharp. Yep, looks like it's still building, which I should have done prior. But what's interesting is that you can do C# and you can do JavaScript. You can do it. I'm on a Mac and all from VS Code, which was really nice. So the local debug experience was quite nice. And then the last thing he talked about was cores and how easy that was to turn on. So I'm going to come over here to my functions project. So this is the functions project running in Azure. These are all of our API endpoints. And if I come to platform features, I'm going to come over to cores. And then these are all the allowed origins, right? So any of these sites in here are allowed to access this API. If they're not in this list, then they get denied. But what that allows me to do is I can actually debug locally. So I can come here and say, this will work. If I did that, if I added that in, I would now be able to debug this thing, my production API, or hit it from my local host, and then I can pull it back out again when I'm done to make sure that other people and their local hosts can't access it. All right, so that's the good. Let's take a look at the bad. So some of the bad things about JAMstack applications or serverless web apps. There's a few. It's not all cool technology. And can y'all see my PowerPoint again?
Everything.
Yes, you can see it?
Yes, we can see it.
Yes.
Okay, perfect. Just checking back. All right, so let's take a look at some of those bad things. One of the things that's difficult was AUTH. So when you're building an application that doesn't have a server component like we had, the authentication becomes more difficult because all you have is a browser. You don't have a server to deal with. And so we used something called EasyAuth in Azure to get that authentication mechanism that you saw, where I logged in with Twitter. And it was relatively easy, but authentication just in general is not easy to do. I've been coding web applications for, for almost 20 years now, and I have never, ever built a login screen and then thought, that was fun, let's do that again, right? It's just a difficult thing to do. And it's a difficult thing in JAMstack applications as well, and actually a little bit more difficult. The hosting was a little bit difficult for us because we just couldn't figure out how best to do it. Now, once we figured out that Azure or that storage was the right way to go about it, it became very, very clear and relatively simple to do. But it actually took us quite a while to figure that out, that was the right way to host that application. Another thing that was tough was the metrics. So we didn't have hardware, so we've lost control of our environment and the ability to look inside, see what's going on, see how many requests we're getting. Now, you saw me do that, but we had to figure out that application insights is how you solve that problem. So it is a problem. If you build a JAMstack application, you lose the ability to get telemetry on the thing from start to finish. But we were able to use application insights to bridge that gap, which ended up working out really, really well. So let's talk about the ugly parts, because there are some parts of this thing that were fairly ugly. One of them is that we had to provide a proxy for our application. So when you go to our application, if you go to the urls.com, it actually makes calls to the urls.com/API/some method. Well, how does that work? Because the API and the front end are not running on the same place. One's in Azure Storage and one's in Azure Functions. And so we used this proxy service in Azure called Front Door, which allows us to define a bunch of different pools and then to basically put a facade on the front and say all of this stuff sits behind the urls.com. If someone tries to go to /API, send them this direction. If they try to go to the front end, send them this direction. Now, we were able to solve that problem with Front Door, but until we figured that out, that was a very difficult thing for us to do. The networking part of this is hard. The DNS is hard. It is difficult in Azure to get a root domain name for something that is running in Azure Storage. So in Azure Storage, you get this domain it's kind of funky. It's got this weird like Z character in it. But if you wanted to bring your own domain, if you're setting up that domain, you need to set up what's called a CNAME, at least for www. And when you do that, you would point that at this URL that's auto-generated that Azure Storage gives you. And that works. That works very well. But what happens if you just want people to go to your root domain? So instead of www.theurlist, it's just the URL list. Then things get more difficult, because in order to do that, DNS requires that you have an IP address. But Azure Storage doesn't give you an IP address to go to. So what do? Well, in our case, we ended up using Cloudflare, and we flattened our CNAME and added a redirect rule. So we basically take all traffic that comes to the urlist.com and we redirect it to www.theurlist.com. Now, all of these are separate talks in and of themselves. We could spend an hour looking at just the DNS there, but you should just know that if you set out to build one of these applications, the DNS part is not fun. And then the last thing that we need to talk about is cold start. This is a tricky one. For serverless components, like our API, when the API gets called, well, let's back up. We already said that in Azure Functions, you don't pay if you're not using it if it's not running. Well, how does that work exactly? If it's not running, then how can I call it? So the way that Azure Functions works under the hood is that you make a call to an Azure Functions endpoint. If the function isn't running, what Azure Functions does is it pulls your project off of disk and sticks it into memory. So it's now hot, it's now running. And then it keeps it there for about 5 minutes. And so as long as someone is hitting it, then that gets extended. All right, so every time somebody hits it, the 5 minutes starts over. So what happens after 5 minutes if no one is using the site? Well, Azure Functions takes your site and puts it back on disk. It's no longer hot. That's why you don't pay for it when you're not using it. But the trade-off is there is a delay between the time that it comes off of disk and the time that it goes into memory and becomes hot. And we call that cold start. A cold start time can be upwards of about 3 seconds, which seems like not a big deal. And that's actually really fast when you consider what Azure Functions is doing in the background. The problem is, if you're the first person to hit that API and the API takes 3 seconds to return data, that's going to be quite noticeable to you. And every serverless platform has this problem. It doesn't matter if you use Azure Functions or Lambda or GCP, cold start is an issue on all of them. It's a trade-off that you're making by saying, we're saying, okay, you don't have to pay for the API if it's not being used. The trade-off is if it's not being used, we're going to put it back on disk so that we don't have to pay for it either. The technology on this is getting better. We're making it faster, and actually we've decreased cold start time. Used to be upwards of 6 seconds, and we've halved it. And we plan on having it again, and we're going to have it again until we get it down to where it just isn't there anymore. But right now, that is the case. So all of this, I want to sort of wrap this up by showing everyone what the cost of this thing actually looks like in practice. So I'm going to bring you into the Azure portal here. I assume everybody can see my portal screen?
Yes.
All right, and let's go to cost analysis. All right, so what this is going to do is pull back and show you how much we're actually paying for the URL list. So I want to point out. I'm sorry?
We can see the screen.
Oh, okay, let's see here. Yeah, something happened to stop sharing. Is it working now? Can you see it now?
Not yet.
Yeah, it doesn't seem to be. I'm clicking share. Oh, hold on.
Okay, now we can.
Okay, perfect. All right, so this is our cost. So what I want you to see here is that it's $95.48 per month. Why is that number so high? Well, let's take a look. We need to, let me back up here. So let's look at, because we're in the new, let's look at the last 30 days. If we scroll down here and we look, there's a couple different things that are relatively high cost. So one of them is this Azure Cosmos DB. Now, Cosmos DB is what we're using for our database. And in Cosmos DB, previously, the cheapest thing you could do is pay $25-ish a month for 5 collections, I think, and a certain amount of bandwidth. But we just launched a free tier of Cosmos DB. And so we've moved the URL list over to the free tier. And so our cost next month, and actually let's go back and see what it is so far, if we did it right at least. So let's go to this month. Our cost should be relatively low. Yeah, so now we're running $2.40 on Azure Cosmos DB, and that's going to be, part of that probably is going to be left over from before we switched it over. So that's one cost that we were able to get rid of. But look at this other cost here. This $53.94 is coming from Azure Front Door. That's that proxy that we use to glue all of the pieces of this application together. That's quite a lot. And Azure Front Door is providing a lot of things to us. It gives us an SSL cert, it gives us routing, and it gives us rules, and it gives us basically complete control over the networking of the thing, but we're paying quite a bit for it. We are addressing this in Azure by sort of making this part of the CDN, Azure CDN, which we're not currently using. We're using Front Door instead. They're similar services, but not the same. And we're going to try to get this cost down as well to where you only pay for what you use. And then the last thing I want to point out is this $9.22 here on the bandwidth. So what's really interesting about the cloud, and what I find a lot of people don't understand, is that you have to pay for bandwidth in the cloud. And what I mean by that is you pay for the data that comes out of the cloud that you pull out. So in the case of the URL list, anytime someone loads that page and it pulls out data, right? So anytime someone comes here to this build 2019, it makes an API call, data is pulled out of Azure. We pay for that. Now, it doesn't seem like it's very much. Bandwidth is, I think it's like 0.8 cents per gigabyte, which seems cheap. But think about it this way. If you have an application and you have a web app and you have let's say you have a 25 megabyte image that you're serving up in that web app. Now, let's say it's 5 megabytes, which hopefully you wouldn't do that, but that's done all the time, right? We stick images in our apps. We don't check the size. So you're serving up a 5 megabyte image, and you serve that 5 megabyte image 20,000 times or 25,000 times, I think it is. That's actually, if you do the math on that, it ends up being $20 in bandwidth charges. So you have to be very conscious that when you put things in, and this is true on every cloud provider. It's true for Amazon, it's true for Azure, it's true for GCP, it's true for places like even like Netlify. Now, Netlify doesn't charge you for it. They actually eat the cost, but it actually is there. Bandwidth charges are expensive everywhere. So I just want to make sure that everyone knows and is aware so that when you go and work with cloud providers in the future, you know that it's free to put your data in the cloud. It is expensive to take it back out. And in Azure, you can even move it between data centers, and that's okay. But if you take it out of the regions, then you start to pay for the bandwidth. So if you take one thing from this presentation, just know that no matter what cloud you're in, you have to pay for bandwidth. All right, we'll just keep on sharing this one screen here. So let's just round this out. These are the good things about JAMstack apps. Cost, speed, scale, and the local dev. The bad, auth is tricky. Figuring out where to host it was hard, but we got through that and found Azure storage. And then telemetry is difficult, but application insights is really good for that. You can track your whole app. And then lastly, the ugly, you can really boil the ugly down to networking and DNS. It's tough. We solved it all with Azure Front Door, but we're paying for it, as you can see in the metrics. And then the cold start of Azure Functions. Although I will say, because we used a front-end application and we're doing everything asynchronously, it's not that bad. The application loads and the API takes some time, but it isn't a bad experience. We found that even if you have to wait a couple of seconds, it's not terrible because the application does load immediately. It's the loading of the app that's important, not the speed of the API. All right. That is it from me. If we've got some time left, I guess we could do some questions. That sounds good.
Okay, we have a question from Josh, and I think he just, okay, it's mostly me having the questions. It seems,
oh, okay.
I don't know whether people are confused about the stack or whether they understand. I hope they do. So one of my questions is, can serverless work with sockets?
Yes, so that's a great question. So can serverless work with sockets? What we're talking about there is, can you get real time with serverless? Yes. In the case of Azure, the way that you would do this is you would use an Azure function, and then you would use Azure Signal R. And you would tie those two things together and use them in conjunction, and Signal R will provide the sockets, and you can talk back and forth between those two things.
Okay, and is Signal R limited to .NET developers, or can JavaScript devs use it as well?
Yeah, JavaScript devs can use it as well. So there's an SDK for C#, obviously, but then if you go to NPM, there's a package for JavaScript.
Okay. The next question we have on the chat is, do we have other options for building JAMstack apps other than JavaScript, for example, Elm?
I don't know about Elm, so I don't know. What I can tell you is anything that compiles down to just HTML, CSS, and JavaScript will work. And as long as the compilation doesn't have to happen on the server, it happens during, the build of the actual app. So for instance, Hugo, which is written in Go, generates static sites, works just fine for JAMstack.
Okay. And do static generators also count as JAMstack apps, such as Hugo?
Yes, that's a phenomenal question. Yes, they absolutely count as JAMstack applications.
Okay. So far, those were the questions. Do you have any final remarks?
No, that's it. I actually think I've talked too much.
Yeah, that's relative. It's we are yearning to learn.
Okay.
Well, everybody, thank you for having me. You can find me on Twitter. If you want to reach out, I'd love to hear from you. And if you're doing things on JAMstack, got other questions or questions about Azure, feel free to hit me up.
Yeah. So hi guys, can you hear me?
Yes, we can.
Yeah, so I actually have a question, just that I didn't type it in the chat. My experience with serverless before I started learning Azure has mostly been on AWS Lambda, and in most recent developments we have the Lambda serverless application model, which makes it very easy to bootstrap serverless applications and also deploy them, because it creates some form of infrastructure as code wrapper. I'm just curious if you know of any alternatives that achieves similar results on Azure.
So I'm not sure that I fully understand the question there. Are you talking about like Amplify, or I don't know that yeah, go ahead.
So AWS Lambda have built what we call the serverless application model, or SAM for short. So, and what that tool or platform does is it kind of generates some YAML file that represents your serverless infrastructure. So you can basically use Docker containers to like emulate the entire infrastructure locally. Then also you can edit the YAML files if you want to include other services into your serverless application that are on the AWS cloud. And I have not seen a similar alternative to doing such stuff on Azure. So I was just curious if Burke, you know of such.
Yeah, I got you. So the way that this works in Azure is you first download the Azure Functions core tools, which allows you to do everything locally, allows you to create your environment locally, run it locally, debug it locally before you deploy it. To use other Azure services with Azure Functions, there's something called bindings. So the concepts are different here, but with bindings, you can bind to different things, and then they just show up in your code as objects that you can work with. So for instance, with Cosmos DB, you could specify in a JSON file, I want to bind this function to this database as an input. Here's the connection string. And then in your code, you get this context object. And on the context object, you will find your database and all your tables. So that's true for things like Event Hubs, Event Grid, Logic Apps, different services within Azure. So I think the concept you're looking for there is called bindings.
Yeah, okay, got you.
We have one question in the chat. If I am beginning a career in web development, what is the best way to go? Should I learn PHP, that dreadful language? Sorry for my bias, or should we go the JAMstack way?
Yeah, that's a great question. I mean, it's so hard to say, you know, but I really think that the right thing to do, if I was giving advice at this point, looking down the road, is to learn a front-end framework, and React is probably the best thing to invest in at this point. So I would learn React as a front-end technology and how to build web apps with that.
Okay. One question from me. So I recently bumped into a technology called Kubeless. I don't know whether I'm pronouncing that right, but it enables you to build your own serverless infrastructure from scratch using Kubernetes. Would you recommend this approach, or what should we just use the existing infrastructure?
I don't know anything about that, but if building your own serverless infrastructure sounds like fun, I say do it.
Okay, thank you. So I believe that is the end of our session. Thank you so much for attending this session. It's I believe it has been informative to everyone. And you have mentioned your Twitter handle, I believe, and I hope that you'll also share the resources after this session.
Correct, yes. I'll send you a URL link with all of the resources for the session.
Okay, thank you, and have a good day since in your timeline, and for the rest of us in Kenya, have a good night.
Thank you for having me. Have a good evening.
Okay, thanks.
Okay, thank you.